Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Minimize XOR, Leetcode 2429. In this problem, we are given two integers, num1 and num2, and we have to find the positive integer x such that x has same number of set bits as num2 and the value x XOR num1 is minimal. Note that XOR is the bitwise XOR operation, and in the end, we should return the integer x. And the test cases are generated such that x is uniquely determined. The number of set bits of an integer is the number of ones in its binary representation. Then in example 1, num1 is 3 with binary representation 0, 0, 1, 1, and num2 is 5 with binary representation 0, 1, 0, 1, and our answer x is 3 with binary representation 0, 0, 1, 1, as it has same number of set bits as num2, which is 2, and the value 3 XOR 3 is minimal compared to any other number with the same number of set bits as num2 equal to 5. Similarly, in example 2, we have num1 with binary representation 0, 0, 0, 1 and num2 with binary representation 1, 1, 0, 0. And now our answer x will be equal to 3 with binary representation 0, 0, 1, 1 because it has same number of set bits as num2 and 1 XOR 3 gives us 2, which is minimal compared to any other number with the same number of set bits as num2 equal to 12. Now in terms of solution, we need to find the integer x such that it has same number of set bits as num2 and the value x XOR num1 is minimal. So first we need to count the number of set bits in num2. We can use various approaches here, which we have already covered in the problem, number of 1 bits, including the popular Bryan-Kernigham's approach. Feel free to check out the I button for more details in case you are interested. Also, sometimes interviewers prefer not to use inbuilt or standard library functions, so we should know these methods. To keep the solution simple and clean, I will be using a library function to count the set bits. For example, in Java, we can use integer.bitCount and pass in the number. Or in Python, we can convert a number to string and then count number of ones in it. Next, we need to find the value x such that x XOR num1 is minimal. So that means x should have the set bits in the positions where num1 has ones as well, because if we XOR 2 bits, the result is 1 if the bits are set, but 0 if the bits are the same. For example, 0 XOR 0 is equal to 0, 1 XOR 1 is equal to 0, but 0 XOR 1 is equal to 1 and 1 XOR 0 is equal to 1 as well. So to minimize x XOR num1, we should try to set the bits in x at the position where num1 has set bits. This way the XOR operation will produce 0 at this position, reducing the overall XOR value. Now there are three cases to consider. Let A be number of set bits in num1 and B be set bits in num2. First, let's look at the case when B is less than A. That is, number of set bits in num2 are less than number of set bits in num1. For example, consider num1 equal to 29 with binary representation 11101 and num2 equal to 5 with binary representation 101. The number of set bits in num1 and num2 are 4 and 2 respectively. So we need to construct the answer x with 2 set bits, which is the number of set bits in num2. And now the question is, where should we set these 2 bits such that it minimizes x XOR num1? Think about it. Where will placing these bits have the most impact in terms of reducing the XOR value with num1? And the answer is, we should set them at the most significant bit positions, where num1 has set bits. This is because nullifying the value at the most significant bit will have the greatest impact in reducing the XOR value. So this is the 0th position, this is first position, this is second position, and so on. So the 0th bit or the rightmost bit is the least significant bit, and the leftmost bit is the most significant bit. So in X, the bit set will be at position 4 and 3, and rest of them can be zeros. And now we have 2 set bits which match with number of set bits in 5, that is num2. So now if we do the XOR between X and num1, then these 2 bits will cancel out. But 29 still have 1 and 1 set on 0th and second position. So in the output, they will be set. So X XOR num1 will be equal to 5, which is minimal compared to any other choice with the same number of set bits. So our answer will be x equal to 16 plus 8, that is 24. And now we come to case 2, where b is greater than a. For example, consider num1 equal to 5 with binary representation 101 and num2 as 29. with binary representation 11101. The number of set bits in num1 and num2 are 2 and 4 respectively. And we need to construct answer x with 4 set bits, which is number of set bits in num2. So we start by aligning the set bits in x with those in num1 so that XOR 5 is minimized. So we set a bit at position 2 and 0, but to match with number of set bits in 29, that is 4, we still need 2 more bits to place. And again the question is, where should we place these 2 extra bits? These additional bits will result in set bit in XOR num1 because in num1 for these bits there will be a 0, so in the output we will always get a 1. So therefore, to minimize the overall value, we should set these extra bits at the position where they will contribute the least to the XOR result, that is at the least significant bit positions. So for that we will go from left to right from bit position 0 to 31, and we see that first bit position is set, so we move on. Then the next bit position is not set, so we will set 1 here. Then at bit position 2, bit is already set, so we move on. And finally we come to bit position 3, which is unset, so we will set a bit here. And now we have set all the 4 bits. So our x in binary representation will be 1111, which is equal to 8 plus 4 plus 2 plus 1 equal to 15. And XOR num1, that is 15 XOR 5, will give us 1010, which is equal to 10, which is minimal compared to any other choice. And finally comes the last case where b is equal to a. For example, take the number 14 with binary representation 1110 and number 11 with binary representation 1011. So 14 and 11 both have 3 bits set. So our number x should have 3 bits set, and we can place these 3 bits exactly at the positions where there are ones in num1 as well, so that when we do XOR num1, these bits will cancel out and XOR num1 will be equal to 0. But we don't need to handle this case explicitly as it is already covered by case 1. So then in summary, our approach will be that we count set bits in num2, store in some variable say count, and now we will iterate from the most significant bit position, that is we start from bit position 31 to 0. And if a bit is set at num1 and our count is still greater than 0, we can set the corresponding bit in x as well and decrement the count by 1. But how do we know in num1 if ith bit is set or not? We can create a bit mask to check only the ith bit by left shifting 1 by I positions. For example, 1 in binary is 001 and 1 left shift 0, that is 1 left shifted by 0 positions will give us 1 back. Similarly, 1 left shifted by 1 will give us 0010 in binary, which is decimal 2. 1 left shifted by 2 positions will give us 0100 in binary, which is 4 in decimal. 1 left shifted by 3 positions will give us 1000 in binary, which is 8 in decimal. And the AND operator returns 1 when both the inputs are 1. So now if we perform the bitwise AND between num1 and this bit mask and we get the value as 1, that means ith bit in num1 is set. So this is how we know if ith bit in number is set or not. And now the question is, how can we set the ith bit in our answer x? And for that we can look at the OR operator. The OR operator returns 1 when either of the bits is set. Therefore we can use this operator to set the ith bit in the answer x and then decrement the count of set bits by 1. So now we have handled the case 1 where number of set bits in num2 are less than equal to number of set bits in num1. But we still need to handle the case when number of set bits in num2 are more than that in num1. So to set these remaining bits, we will have to set them at the lowest significant bit positions. So we iterate from the least significant bit, that is position 0, to the most significant bit, that is position 31. And if the bit position in num1 is not set, that means the corresponding bit in our answer is also not set and count is greater than 0, then we will set this bit in x and decrement the count by 1. And once we are done with both the passes, we will return our answer. Now in terms of time complexity, if we look at the forward pass and backward pass, we are running 32 iterations each time. So because of this, the time complexity will be O of 64 or O of 1. And this is because most programming languages have 32-bit integers. But in general, this will be proportional to number of set bits in num2. And in terms of space complexity, it will be O of 1 because we are using some variables here and there. Now let's jump into the code part. First, let's initialize the variable count to store the number of set bits in num2. Let's also initialize our answer. Now we will iterate through most significant bit to the least significant bit. that is from bit position 31 to 0, and we will check if ith bit is set in num1 using the AND operator with bit mask. And if it is and count is greater than 0, then we will set the ith bit in the answer using the bitwise OR operator and bit mask and decrement the count by 1. Similarly, in the second pass, we will iterate from least significant bit, that is index 0, to the most significant bit, that is index 31. And if at any point the count becomes 0, we will stop. And this time we will check if ith bit in num1 is not set. And if it is not, then we will set that bit in our answer and decrement the count by 1. And once we are done with both the passes, we will return our answer. Now let's submit this code. Cool. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.